to object and dynamic model. Okay, textbook is for this chapter object oriented modeling and design by Rambagh. Then of PHI publication. Then before start the chapter, we know the concept of object modeling. Object modeling develops the static structure of software system in terms of objects that identifies the objects, the classes into which the object can be grouped into and the relationship between objects. Object modeling develops the static structure of software system in terms of objects which identifies objects, the classes into which objects can be grouped into the relationship between different objects. It also identifies the main attributes, the operations, characteristics of each class. The process of object modeling can be visualized in following steps. Identify objects, group into classes, identify relationships among the classes, create user object model diagram, define user object attributes, define the operations that should be performed on the classes, and review glossary. Then what is a dynamic model? After the static behavior of system is analyzed, its behavior with respect to time and external changes needs to be examined. And this is the purpose of dynamic modeling. Dynamic modeling can be defined as the way of describing how individual objects respond to the event, either internal event triggered by other objects or external events triggered by outside the world. So in object model we have studied what the object can be done, not how it can be done. But in dynamic model we will study how the object can act regarding the event. So the process of dynamic model can be visualized in the following steps. Identify state identify state of each object, identify events and analyze the applicability of the actions, construct a dynamic model diagram comparing comprising of state transition diagrams, express each state in terms of object attributes, validate the state transition diagrams drawn. This is the dynamic model. In object model, we have studied what the object can be done, but in dynamic model, we will study how the object can be act with respect to its event, either by internal attributes or external attributes. So, and in functional model in chapter 4, functional modeling is the final component of object-oriented analysis. The functional model shows the process that are performed within an object, how the data changes as it moves towards between the methods. It specifies the meaning of operations of object modeling and the actions of dynamic modeling. The functional model corresponds to the data flow diagram of traditional structured analysis. The process of functional modeling can be visualized in the following steps. Identify all the inputs and outputs, construct data flow diagrams showing functional dependencies, state the purpose of each function, identify constraints, specify optimization criteria. This is introductory part of functional modeling. Then what is structured analysis and object oriented analysis? The structured analysis or structured design approach is a traditional approach of software development based upon the waterfall model. The phases of development of structured analysis or structured design is feasibility study, requirement analysis, specification, system design, implementation, post implementation review. And now we will look the relative advantages, disadvantages of structured analysis approach and object oriented analysis approach. So a dynamic model represents the time dependent aspect of a system. It is concerned with temporal changes in the states of object system. The dynamic model is regarding with the time dependent. Suppose in case of the examination, there is a time specific examination. You are given the quiz of 15 minutes. After 15 minutes, you cannot give the examination. This is a dynamic model. It is time dependent aspect of system. What is the state? The state in which the situation at a particular condition during the lifetime of object. Transition transition is a change in state from one state to another state, that is a transition. Then event, an occurrence that triggers the transition, that is the event. An action, an uninterrupted and automatic computation that occurs due to some event. And concurrency of transitions. Suppose you want to set alarm at 5 o'clock, then what will be the state, what will be the transition, what will be the event, and what is the action? State, it will show the what is the exact alarm time is equal to current time. If it is okay, that is the transition, then it gives the event, that is it will be ringing, that is the action. But if it is not okay, then it does not change its state and it does not give any action. So a state machine model is a behavior of an object as it passes through the number of states in its lifetime due to some events as well as the actions according to the events. The behavior of object that it passes through the number of states in its lifetime due to some events and the actions occurring during the events. A state machine is graphically represented through the state transition diagram. Then state modeling. State modeling that describes the sequences of operation that occur in response to the external stimuli. The state model consists of multiple states diagrams, one for each class with temporal behavior that is the important to an application. The state model consists of number of state diagrams, one for each class with temporary behavior which is important to applications. So state diagram is a standard computer science concept that relates with events and states. What is the event? So an event occurs at a time such as user depress the left button or Air Deccan flights departs from Bombay. That is the event. Event is someone occurs at a particular time. So event happens instantaneously with regard to time scale of application. One event may logically precede or follow another. One event may be follow the another, or two events may be unrelated, concurrent. They have no effect on each other. Events include error condition as well as normal conditions. There are three types of events: signal event, change event, and time event. So, signal event is one-way transmission of information from one object to another object. When you're traveling on a road or highways, there are some signal or traffic signals. The red signal shows the stop, yellow is the yellow signals to be ready, and green signals shows the go. And there are some directional signals, left, right, forward. So this signal events, it is a one-way transmission, only give the transmissions. It is simplex, one-way transmission information from one object to another object. Signals on traffic signals gives the information whether we want to go forward, left, right, uh, ready to go or stop. This is the one-way information from signal to that driver or person. That is one-way information. It is a different from the subroutine call that returns a value. An object sending a signal to other object may expect a reply, but reply is not a separate signal under the control of second objects. The object sending a signal to another object and reply expect reply, but reply is a separate signal under the control of second object, which may or may not choose to send it. The signal event is an event of sending or receiving a signal. Concern about the receipt of signal. Here in this figure, left side signal shows as string entered, that is a text. Sometimes on road traffic, the signal it gives stop signal in red color, or digits, not turn towards left, not turn towards right. These are in the form of digits, or wait for 120 seconds, 30 seconds. This is the digital signals. And third signal is mouse button pressed, that is button location, left or right. What is this? Is the signal event. Then what is the difference between signal and signal event? A signal is message between objects, and signal event is occurrence in a time. Signal event is occurrence in time, whereas signal is message between two objects. Then a next event is change event. Change event is an event that is caused by the satisfaction of Boolean expression. UML notation for change event is a keyword when followed by parenthesized Boolean expression. So when here example is given, when room temperature is less than heating set point. This is the condition regarding the time. Or second example, when room temperature is greater than cooling set point. A third example, when battery power is less than lower limit, or when tire pressure is minimum or less than minimum pressure. These are the examples of change event from one state to another state. Then third is a time event. Time event is an event caused by occurrence of an absolute time or the elapse of time interval. So UML notation for absolute time is keyword when followed by parenthesized expression involving time. The notation for time interval keyword followed by parenthesized expression that involve time duration. Example: when date is equal to 1st January 2000. Then after 10 seconds, it may be 1st January or it may be 2nd January. Depends on the time. At what time after 10 seconds? That is the current time. Suppose current time is 11 o'clock in the morning, then same date will be displayed. But the time date is 11 o'clock at night, 11 o'clock 59 minutes and 50 seconds. Then after 10 seconds, the date will be changed. It is depend on time. So event occurs at which time? It is important. So time event is an event caused by occurrence of absolute time or elapse of time interval. Then next concept is state. State is an abstraction of values and links of objects.
हॅलो.
Hello.
हॅलो. सर
हा
सर
बोला.
थोडा माईक पुढे पकडता का? जरा थोडस लांब पकडा.
ठीक आहे. ओके. States. A state is an abstraction of value linked of an links of an object. A state of values and links are grouped together into a state according to gross behavior of object. The UML notation state the rounded box containing optional state name, and the list state name is a bold frame center the name near the top of the box, capitalize the first letter, then ignore attributes that do not affect the behavior of object. The object in a class have a finite number of possible states. Each object can be in one state at a time. A state specifies the response of an object into events. All the events are ignored in a state except those are those for which behavior is explicitly prescribed. Then event versus a state. Event represent points in a time, whereas a state represents interval of time. So a state corresponded the interval between two events received by an object. Here example is given: powered on, powered off. These are the two events, and in the interval between two events is known as a state. Here again powered on. Here first is powered turn on power, second is power turn off. Between these two events, the interval between these two events is known as state, and state is powered. Then here's in second position power turn off, then powered on, but in this case not powered. So both events and states are depend on level of abstraction. So the time is required, a time interval between two objects, first object and second object in case of events. The time interval between two objects, first object and second object, is known as the state of that object. Then transition and conditions. Transition as instantaneous change from one of state to another state. Transition is said to fire upon the change from the source state to target state. The origin and target of transition usually different state, but sometimes may be same. Transition fires when its events, that is multiple objects, occurs. Guard condition is a Boolean expression that must be true in order for a transition to occur. Guard condition is checked only once at a time the event occurs, and the transition fires if condition is true. So what is a state diagram? A state diagram is a graph whose nodes are states and whose direction arcs are transition between two states. The state transition diagram specifies a state sequence caused by event sequences. The state names must be unique within the scope of state diagram. All objects in a class execute the state diagram for the for that class, which models their common behavior. A state model consists of multiple state diagrams, one state diagram for each class with important temporal behavior. State diagrams interact by passing events through the side effect of guard condition. The UML notation, that is Unified Modeling Language notation, for a state diagram is a rectangle with the name of small pentagonal tag with the upper left corner. The constituent states and transitions lie within the rectangle. States do not totally define all values of an object. If more than one transition leaves a state, then the first event to occur causes if the corresponding transition to fire. If event occurs and no transition matches, the event is ignored. If more than one transition matches of an event, then only one transition will fire, but choice is non-deterministic. These are the conditions regarding the state diagram. Read the all paragraph carefully. Question may be asked for 4 marks. Explain state transition diagram or state diagram. Then event classes and attributes. What is event classes? Suppose airplane department departs. Airplane departs. So airplane departs have airline, flight number, and from the city to the city. So this is the event class regarding airplane departs. So what is the event? So airline is United, flight number is flight 23 and departs from the city Rome. This is the event, and airplane departs, airline, flight number, city. This is the event class. This is in brackets airplane, flight number, city. These are the attributes. Using this attribute, we can explain the concept of event. In case of mouse button pushed, this is event class. Its attributes are button and location. So what is the event? A right button or right mouse button is pushed at 2030. That is the location number. Then in case of phone receiver lifted, event is phone receiver lifted. Then in case of digit dialed, attribute is digit. So event is digit dialed 2. If dialed digit is 2. If dialed digit is 3, then digit dialed 3. These are the events and event classes and attributes. Suppose a scenario regarding the phone call. In now everyone is using mobile, but in 10 years, 15 years ago, there is a telephone. So telephone, the see the concept of telephone. This is state a diagram regarding the telephone. See the whole figure carefully, then we will explain this figure. Hello. Have you seen the state diagram of phone line? So initially the receiver is in ideal state on the hook. If we can lift the receiver, that is off the hook, then we can hear the dial tone. Okay, if we are dialing some number, so dialing one digit, then dialing second digit, then dialing third digit, fourth digit, fifth digit, and so on. If number is valid, then it will connecting. Sometimes you receive a busy tone, that is number is busy, you will receive the message and you put the receiver on the hook, that is it can become ideal. Sometimes it you will get after connecting trunk busy, that is fast busy tone, then the receiver will be, you will stop and receiver will be the on the hook, so that it can become ideal. Or whenever the connecting the phone, they routed and go to the ringing. Sometimes you want to give a missed call, then stop the ringing and receiver to the hook, and so that it can become ideal. Or while ringing, phone will be the connect and you will get answer. After some communication you want to disconnect, then the receiver will be on the hook. Sometime whenever you are receiving the receiver from ideal state, you will hearing the dial tone and you will keep the receiver on the hook. Or some odds, or some time dial tone stops and you will get the warning and timeout, the receiver will be on the hook. The same concept is used in here. The question may be asked for 8 marks. Explain state diagram or state transition diagram regarding phone line. So you should have to draw this figure and explain the concept in detail. So this is the scenario for a phone call. First, a caller lifts the receiver. Then, while receiving the receiver, the caller will hear the dial tone, which begins. After dialing some digit, the dial tone ends, and you are dialing that digits. The caller phone begin ringing. The ringing tone appears in calling phone. The called party answers. The called phone stops ringing. Ringing tone disappears in the calling phone. Phones are connected. The called party hangs up. The phones are disconnected and caller hangs up. This is the points of scenario for the phone call. We'll see the event trace diagram for this phone call. Before that, we will see the what is event trace diagram. So each event transmits the information from one object to another objects. In case of phone line, you have studied while receiving the receiver, So receiver is one object and another object is the person or caller or receiver. The receiver gives the dial tone. So this is the signal or event transmits information from one object to another object. The dial tone begins event transmits a signal from the phone line to the caller. This is in this case the dial tone is a signal from the phone line. This is phone line is one object, caller is the another object. So phone line gives the signal in case of dial tone to the caller. That is the event. So in event trace, identify sender and receiver objects of each event. So event trace diagram shows the sequence of events and objects changing these events. So event trace diagram shows the object as a vertical line and each event in horizontal line. Object as a vertical line. In this figure, caller, phone line and callee. These are the objects in vertical line and horizontal line event. Horizontal lines are the events. These are the events occur between these objects. So in case of phone line, there are three objects caller, phone line and callee. When the phone line in ideal state, the first object that is caller, receiver, receive caller lifts the receiver. So this is the first event receiving the receiver or lifts the receiver is the first event. So reply for phone line to caller is dial tone begins. Then another reply from caller to phone line dial a number so that dial tone ends. Dial a numbers. After dialing a particular number, if the number is valid, then the phone line gives the ringing tone to the caller as well as phone rings to the callee. In case of callee, the receiver receives an answer to the phone. So ringing tone stops. When ringing tone stops, then here phone is connected. So caller to callee, they are communicate to each other. After communication, callee stops and hangs the receiver, and connection is broken. And caller also hangs the receiver. This is the event trace diagram for phone call. The question may be asked for 4 marks. Draw and explain event trace diagram for phone call. So you should have to draw this diagram. Then next, state. State is an abstraction of values and links of objects. A state of values and links are grouped together into state according to the gross behavior of objects. Hmm. Example of state is in case of object either will be solvent or insolvent depending on its access. Okay, state often corresponding to in case of grammar of English verbs with suffix ing, that is waiting, dialing, or some conditions in previous conditions or during some conditions powered, below freezing, after freezing. So state may be characterized in various ways. Here, one way to characterize state is, suppose I want to set an alarm at 5 o'clock or a particular time. Then, what will be the condition? So, first state is alarm ringing, and description of this state, alarm on watch is ringing to indicate target time. This is the description. What is the event for this state alarm ringing? So set the alarm at target time. Any sequence not including clear alarm when current time is equal to target time, then alarm will be ringing. This is the event sequence. First set the target time, then check current time is equal to target time, then the alarm will be ringing. What is the condition? Condition for this alarm ringing, alarm on, alarm set to the target time, target time is less than equal to current time is less than equal to target time plus 20 seconds. So that alarm will ring up to 20 seconds or 1 minute, whatever the time you have set exit time. So no button has to be pushed since the target time. So when current time is equal to target time plus 20 is the alarm will ring up to 20 seconds. So response is reset alarm and next state will be the normal. If button pushed, any button pushed, then reset alarm and state will be the normal. Then this is the characteristics of state events while setting or alarm ringing. Then transition and condition. A transition is an instantaneous change from one state to another state. A transition occurs when its event occurs, unless an optional guard condition causes the event to be ignored. A guard condition is a Boolean expression that may be true in order for the transition to occur. The choice of next state depends on both of the source state and the event received. Then what is the state diagram? We have seen the state diagram with the for the phone call. The state diagram is a graph whose nodes are states and directed arcs in transition between states. A state diagram specifies or describes state sequences caused by event sequences. A state name must be unique with the scope of state diagram. All objects in a class execute state diagram for that class. The object state diagram models the common behavior of the class object. This is the state diagram for phone line we have the scene. Then one shot diagram for chess game. Question may be asked for this also. For chess game, there are two types of or two colors of in chess there are two types, white white object and black objects. When white turns starts from the white turn, so if it starts, either it will give the checkmate condition or stalemate. In case of final states we are saying, in case of final states of a, while the playing the white turn, either it will give the checkmate or stalemate. In case of checkmate, it will black will the win, or it will stalemate it will be the draw. Similarly, in case of black moves or black turns, it will give a stalemate or the checkmate. So in case of checkmate, white will learn, white will win, or in case of stalemate, the game will be the draw. This is a one shot diagram for a chess game. Then a nested state diagram. So this is the example of vending machine. So nested the diagram, state diagram within state diagram is a nested state diagrams. We will see the concept nested state diagram and others activity diagram we will in next lecture. Okay, we stop.